Hey there everyone, welcome back to the channel. Today we are going to discuss this problem, that is valid anagram. And let's first go through the problem statement. So we are given with two strings S and T. We have to return true if T is an anagram of S and false otherwise. An anagram is a word or a phrase formed by rearranging the letters of a different word or a phrase, typically using all the original letters exactly once. Okay, so basically in simple terms, what they are trying to say is, if you are given with any string, let's say S, and in the string they have written anything, let's say they have written code. So if I ask you to form any anagram of this string, that is of string S, what you can do is you can just jumble up these characters here in the string. Let's say you can rewrite this by jumbling the string as the in such a way like OCED, right? So what you did over here is you didn't change the original number of characters which were present earlier in the string. So let's say in the string the C was present only once, O was present only once, D was present only once, and similarly frequency of E is also equal to 1. So what you did to make an anagram of the string S is you have just jumbled up the letter. You haven't changed the frequency of elements. You haven't changed the length of the string. You haven't done anything. What you simply did was you just made one permutation of many possible permutations out of the string S, and when you are able to do it, you can call it as an anagram of S, right? So simply an anagram is nothing but whatever string is given to you, you have to just jumble up that sequence, and if you jumble it up, whatever you get as a resultant is called as anagram of that particular string. Make sure that whenever you are making anagram, the frequency of each and every element which is present in string S and in its anagram will be the same, and the length of the string S that you are taking and the anagram string that you are making from string S will also be the same. So these two things that you have to keep in mind. And now, as you know now, what is anagram? So it is very simple. Now if I ask you that, let's say I have given you this string that is S, which is code, and along with this let me give you the string T, which is OCED, which is one of the anagram of S. Now if I ask you that if T is anagram of S or not, tell me what is the simplest way to do this. Now here you can see that, as I told you, that the frequency of each and every element which is present in string S and which is going to be present in its anagram will be same, right? This frequency will remain same, the length will remain same, only the sequence of character in which they were written will be changed. That's it. So what you can simply do is, so you can sort this string, you can also sort this string. Whenever you sort both of the string, if they have same frequency of all the characters, then you will be able to get string S is equal to string T after sorting them, correct? Because as we know that, let's say there are some three number of A present in string S, okay? So if we make anagram, that is, if anagram of string S is T, then in T also this A will be present three times, correct? So whenever you will sort at the starting of the string, you will get something like this, that is 3A. And here in the anagram of the string S, you will again get something like this, that is 3A. Okay, so basically the anagram of the string S and the string S itself, after sorting, they will be same if this T is anagram of S. So we have the simple solution, that is sort both of the strings and then check if both of the string after sorting they are equal or not. If they are, then you have to return true. If they are not, then you have to return false. So that was it. That was the simple logic, as well as the problem statement is also very simple. Now let's directly look at the code. So here is the code, as exactly what we have discussed during the logic part. The same thing we have implemented over here. First of all, we have done the sorting of the string S over here. After that, we have sorted its anagram, that is string T, and after that, finally we check that if both the strings are equal, then you have to return true, else if they are not equal, you have to return false. and I have explained you pretty well that why the string s will be equal to t after sorting, and why it is implying that t will be anagram of s. That I have explained you during the logic part. So I hope you are clear with this. This is the most simplest solution that you can think of. Now there is one more method to solve this question using big of and time complexity, that is linear time complexity. Over here, whatever code we have written, we have used the inbuilt sort function, and this uses the time complexity of big of and log n, right? But you can solve this question by just simply using big of n, that is linear time complexity. How you can do it? It is very simple. Just take some extra memory, that is just use hash map and check the frequency of all the characters present in S with the frequency of all the character in T. If the frequency of each and every character of S is equal to T, then T is called as anagram of S, and then you have to return true. And this thing you can do in big of and time complexity, as well as you have to use some extra space because you are going to make one hash map for it. So that was it. That was some two basic simple solution to this question. Now let me just try to submit it. Okay, so yeah, that was it. That was the solution. Now, if you have any query, you can ask me in the comment section, or else I will see you in the next one.